Yes, miss.
Yes, ma'am.
Okay, so do you have any problem? If you have any problem about any topic or any chapter, you can ask me.
Ma'am, I have a little problem. Ma'am, in chapter 6, slide number 13, ma'am, if you could just tell me which process is actually requesting for the resource and which process is actually holding the resource by the arrow sign, ma'am, I'm a bit confused. Ma'am,
Yes, I'm showing it. Tasnia, where you have problem?
ma'am, in chapter 6, slide 13. Yes, ma'am. Here, ma'am, I'm a bit confused. Which process is requesting and which process is actually holding the resource?
Okay. So whenever the arrow is indicate to the process, that means the process is hold resource 1. Whenever the arrow is indicate to resource, that means process 1 is request for resource 2. Do you clear?
Yes, ma'am.
You just look at the arrow, that where the arrow is pointing out. In here, it pointing out to P1. That means process 1 is hold the resource 1. And whenever the arrow is pointing to resource, that means the process is request for that resource. Okay. Okay. Next question.
Ma'am, hello.
Yes, Rubina, tell me.
Ma'am, in case of Viender's algorithm, there are some bugs. Can you give us some, example like how the question will be given in our final exam?
Take for
In case of
example,
algorithm.
there are 4 types of algorithm in chapter 5.
Yes, ma'am. Yes, ma'am.
So, if I give a scenario such like that in the lift, if you think about the queue of the lift, the person who stands to the front of the queue of the lift, he will go first inside the lift. So that is the real life example with first come first served scheduling. Then if you think about that, if I give a real life scenario like there are you have 5 assignments to submit the same day. So at that point of time, what you will do with the assignments? You have total 5 assignments and you have definitely to submit the 5 assignments at the same day. And you have just 1 day at your hand because you does not start to practice your start to complete your assignment. You will go for the largest assignment because the smallest assignment will take less time than the largest assignment time. So that can be the real life example of shortest job next scheduling. Then whenever, if I am talking about like you take 5 books from the library, but there are some conditions in the library that 2 books you have to return to the library within 5 days. 1 book you have to return the library within 6 days, and the last book you have to return the library within 7 days. There are some specific boundary according to the day. So what you will do for the target? At first, you will read those books. That book you can return to the library the earliest time. That means within the 5 days. Then you go for the book which you need to return the last day of the library. That is the example of shortest remaining time. Now, if I say that I went to a library and I want to buy some books, but there are some limited boundary that within the boundary I can buy some books. My first boundary is I can buy the books within 3,000 money. After second boundary is I can buy 2 books from geography, 2 books from mathematical chapter, 2 books from Java. This thing. Now, this scenario directly represent the round robin scheduling algorithm. Do you clear, Rubina?
Yes, ma'am. Ma'am, it would look like you will give us some real life example and we have to explain it within the point of view of operating system.
Yes, that's right. Also, maybe I can give you uh, at first I will give you a scenario. According to the scenario, at first you have to find out that which type of algorithm I am talking about. After that, there this type of table, that process number, arrival time, burst time. Now, according to your logic, you have to complete the algorithm. You have to find out the completing time, turnaround time, waiting time. The logic you are think, the algorithm you are think by this way. I don't ask you that solve this formula using first come first serve algorithm or solve this formula with round robin algorithm. No, I won't give as like that way. I will just give a table with the value and at first I will give the scenario. So according to the scenario, your first duty to find out that which thing the scenario is actually related. After that, there will be the math. You have to find out the math according to the what algorithm you're thinking. Let's see that you are the scenario I give. You are write algorithm name. Whatever you write, you have to give the logic that because of this logic, I am thinking that this is related with that thing. If you can fulfill the logic, you can relate the scenario with the logic. At that point of time, I will accept your answer. But without giving any logic, you just write it down. This is related with first come, first serve. But you didn't give any logic. At that point of time, I don't accept your thing. That so if the answer is right, at that time I also not accept. You definitely have to give me the logic. Do you clear, Rubina?
Yes, ma'am. Now it's clear.
Okay.
Ma'am, suppose
Yes.
you gave the table and we somehow made mistake while calculating the values for the table. Ma'am, will you cut the full marks or just a little bit?
Guys, in the mathematical form, there are separate marks. For calculating time, completing time, there will be some marks. For turnaround time, there will be some other marks. For Gantt chart, there will be other marks. For arrival time, for finding out the waiting time, there will be other marks. So it will vary only that part of mark. But the thing is, if you do totally mistake in the completing time, at that point of time, what will happen? Your all of the other answer also be different. So first of all, don't try to do any mistakes. Do you clear, Tanisha? Or Tasria?
Yes, ma'am. Yes, ma'am. And ma'am, what type of question can come from banker's algorithm?
This type of scenario, I will give this type of scenario. You have to try to relate that scenario that which algorithm is actually related. You don't need to worry that that thing you are thinking whether it is right or whether it is wrong. You just focus on the logic that you have to make the logic that is related with the scenario. That's it. If you can make the logic, at that time you can get the full mark. That's the thing.
Okay, ma'am.
If you have any more question, you can ask. That first come, first serve, that then shortest job next, then shortest remaining time and round robin. Among four of these algorithms, which algorithm is super fast and which algorithm is super slow? Guys, think the answer, and what you think, give me the answer.
Ma'am, should I give the answer?
Yes, Tasnia, tell.
Ma'am, among the four algorithms, the slowest one is first come, first serve. This one is slow. And ma'am, the fastest one is round robin scheduling. Because ma'am, in first come, first serve, no matter how much time the first task takes, it first completes that one and then goes for the second one. But in the round robin scheduling, it actually works according to time.
Okay. So, anyone have any more answer? Okay. Now, let me give you the answer. The fastest actually, the shortest job next scheduling. Because it is at first of all, it is non-primitive. Non-primitive means it does not allow to stop the user work and move forward to the next process. And the second thing is, if the arrival time is same, it definitely go for the short job. But the arrival time is different. If different, so according to the time, the process which is come first, at first it will move for that job, and within that period of time, if another process come with a smallest job but it does not stop the work, is only focus on to complete the running tasks, not for the anywhere else. And if you think about the most slowest algorithm, that is the shortest remaining time algorithm, most slowest, because first of all it is primitive. Always remember that non-primitive algorithms are faster than the primitive algorithms. Always keep in your mind. The second thing, shortest remaining time. At first the processor take that which process come first if the arrival time is different. When it start to do some user task, at that point of time, if another task is come which have the smallest remaining time, it just stop that task and jump to that next task. But you know that whenever it go from one task to another task, the processor go from one task to another task, at that time it actually takes some times, and that is called the swapping time. Whenever it takes some times, it actually lost some times. That's why the shortest remaining time is the most slowest algorithm, and shortest job next scheduling is the super fast algorithm. So according to the faster way, first is the shortest job next, then first come first serve, then round robin, and at last the shortest remaining time. Do you clear, Tasnia?
Yes, ma'am.
Okay. So if you have any more questions, you can ask.
Miss,
Yes, Nisha?
Miss, can you explain the banker's algorithm table, chapter 6?
in Banker's algorithm, there are some information which you already get in the question. The first information is but how many resources are there? So resource 4s are here present. Resource 0, 1, 2, 3. The second thing you get information as how many instances for each of the resources or how many elements for each of the resources. That resource not have 8 elements, resource 1 have 5, resource 2 have 9, resource 3 have 8. In the allocation table, you will find out that process 2 will need 2 elements from resource not, nothing from resource 1, 1 element from resource 2 and 2 elements from resource 3. And from the maximum table, it will give the boundary for each of the processes. That what is the boundary when it takes the resource from each of the process. So the maximum boundary for process not that it can take maximum 3 elements from resource not more than 3. After that, when you go for the algorithm table at that point of time, at first you will start from the sequence that is given in the table. That means from P0 to P4. You have to second keep on your mind the second thing that is at a time you can take just only 1 element from each of the resource. You cannot take more than 1 element. So first of all, I will go for my process not and it take 1 element from resource not, 1 element from resource 2, 1 element from resource 3. That's it. And the flag value will definitely be true. True because you see, it needs 2 elements from resource not, but total elements of resource not is 8. So 8 is greater than 2. That's why the flag will be always true. As the flag is true for all of the resources, that's why the answer of the flag will be true. Then I go for process 1, 2, 3, 4 like this way. After process 4, I just take 1 elements from not and 1 elements from 2. After that, again, I go back to my process not. Now, only 1 element is remaining from resource not and only 1 element is remaining from resource 3. So, I will take these 2 elements and the job is now done, totally complete for process not. So that's why my process not is done at this point. Then I move forward for my process 1, then 2, then 3, then 4. And up to this, the time, it does not take all of the elements when the process fulfill all of the elements, then the job is done. So according to Banker's algorithm, the first process which will execute first, that is my process not, then my process 1, then my process 3, then my process 4 and at last my process 2. Do you clear, Tasnia? Do you clear, Nishat?
Yes, miss.
Okay.